Hello, this is Dr. Hanaa Assil and this is chapter 6 on chemical bonding. So let's review what we know from O-level course, that ionic bonds are bonds formed between metals and non-metals. So how do I know if something is ionic? If I have a metal and a non-metal. The metal loses electrons and becomes positive ion. The non-metal gains electrons and becomes a negative ion, and the ionic bond is due to the strong electrostatic attraction forces between the positive and negative ions. We should know that ionic compounds have a structure that is referred to as ionic crystal lattice. The ionic crystal lattice is a giant three-dimensional structure with regular arrangement of alternating positive and negative ions. So when we talk about something like sodium chloride, we're not just talking about one sodium next to one chlorine. We're talking about a three-dimensional structure in which each positive ion is surrounded by 6 negative ions and each negative ion is surrounded by 6 positive ions. The structure is held together by strong attraction forces between positive and negative ions. So that is what we call an ionic bond. We should also remember that ionic bonds have high melting point and boiling point. Why? Because of the strong attraction forces between positive and negative what? Positive and negative ions in the giant crystal lattice. This is the only time when we say positive and negative ions if we're talking about an ionic compound. This needs a high temperature or high lot of energy to break them and separate the ions. Now, if we're comparing something like magnesium oxide and something like sodium chloride, which one has higher? The magnesium oxide has higher melting point because of the increased charges on the ions, which means stronger attraction forces between the positive and negative ions. You should also remember that ionic compounds dissolve in water, not in organic solvents such as ethanol. Ionic compounds conduct electricity, but only when molten or in solution, not as a solid. Because when they are molten or in solution, the positive and negative ions are free to move. They do not conduct electricity when solid because the ions are not free to move in the solid, rigid, three-dimensional crystal lattice. Okay. The next thing you need to remember is how to write dot and cross diagrams. So let us write the dot and cross diagram for lithium fluoride. You should know that lithium is in group 1. It has 1 electron in its outermost shell. Fluorine is in group 7. It has 7 electrons in its outermost shell. So the lithium needs to lose that outermost electron and become the inner full shell. The fluorine will gain this electron and become a full outer shell, and that means the fluorine in the outer shell, usually when we draw dot and cross, we're drawing the outermost electrons, or what we refer to as the valence electrons. So the fluorine has the 7 electrons of its own plus the electron from the lithium. That means it has an extra negative charge. Do not forget to write that extra negative charge on the fluorine and the extra positive charge on the lithium. When we're talking about magnesium oxide, magnesium has 2 electrons in its outermost shell. It needs to lose them. Oxygen has 6. It needs the 2 electrons from the magnesium, and that means that the oxygen ends up with 6 electrons in its valence shell plus the 2 that it took from the magnesium. So it has an extra 2 negative charges, so 2 negatives or minus 2. Magnesium chloride, magnesium has 2 electrons. It has to give the 2 electrons. It cannot give only 1. Now, each chlorine can gain only 1. So that means that I need 2 chlorines to receive the 2 electrons that are given by the magnesium. So the magnesium ends up with a +2 charge, and each of the chlorines has its 7 plus 1 from the magnesium. So it has 1 extra negative on each chlorine atom. Sodium oxide, we know that oxygen has 6, so it needs 2 electrons, but each sodium can give me only 1, so I need 2 sodiums to donate 2 electrons to the oxygen, and that means that I have 2 of the Na plus ions, and the oxygen has 6 of its own plus the 2 that it will take from the sodium ions, so that makes a -2 charge on the oxygen. These are ionic. Now, if we're talking about covalent, covalent is formed between two nonmetals. So how do I know if something has a covalent bond? If we're talking about nonmetals. And this involves sharing of one or more pair of electrons to obtain a full outer shell. The covalent bond in this case, when we're sharing electrons, is the strong attraction forces between what? Between the bonding pair of electrons and the positive nuclei of the atoms. So each atom has a positive nucleus. The two electrons that are being shared is attracted to these positive nucleus, and that forms what we call the covalent bond. So if we're drawing the dot and cross diagrams for hydrogen molecule, we know that the word molecule means hydrogen with itself. So hydrogen atoms together, each hydrogen has one, and remember that hydrogen is the only atom that needs only one in the first shell, because we're talking about the first shell that can take only two. So each hydrogen donates one and takes one, and they share this pair of electrons between them. When you draw it, you can draw with circles or without circles, that's okay. So if you just draw it with two electrons being shared between them without circles, that's fine. If you prefer to draw it with circles, that's okay. Okay, chlorine molecule means chlorine atoms together. Each chlorine has 7 and needs 1. So if it needs 1, it's going to give 1 and gain and take 1. So they're sharing one pair of electrons. Do not forget to put in the rest of the 7 electrons. So each chlorine is going to share one of its electrons, but it still has 6 other electrons around it, which you should not forget to put in. Water has bonds between one oxygen and 2 hydrogens. That is because the oxygen has 6 electrons in its outermost shell. It needs 2 more. Each hydrogen can donate only 1. So I have 2 hydrogens donating 2 electrons, and the 2 pairs of electrons between the 2 oxygen and the hydrogens are being shared between each of them. Okay? When we share one pair of electrons, that is called a single covalent bond. So water, for example, has single covalent bonds. Now methane is carbon, and carbon has 4 electrons and needs 4 more. If it is making a compound with hydrogen, that means I need 4 hydrogens to give me 4 more electrons. So I either draw it with circles or without circles. Ammonia is between nitrogen and hydrogen. The nitrogen is in group 5, so it has 5 electrons. It needs 3 more. So each hydrogen can donate 1, so I need 3 hydrogens, each donates 1 electron, so that we have 3 single covalent bonds. Do not forget to put in the extra 2 electrons that still belong to the nitrogen that were not used in bonding. It had 5 electrons. We used only 3 to make bonds with the 3 hydrogens, so I still need 2 more, which we call a lone pair on the nitrogen remaining from the 5 electrons. Hydrogen chloride, hydrogen needs 1, chlorine needs 1, so we're going to share a pair of electrons between the H and the Cl. This pair of electrons is what we draw as a bond, so this is a single covalent bond. Oxygen molecule means oxygen with oxygen, and each oxygen needs 2, so each one is going to donate 2 and take 2, so they're sharing 2 pairs of electrons between them. That means we have a double covalent bond between the 2 oxygen atoms. If we're talking about nitrogen, each nitrogen has 5 electrons, it needs 3, so it's going to donate 3 of its own and take 3 from the nitrogen, and they're sharing, and that means that they're sharing 3 pairs of electrons. That means a triple covalent bond. Carbon dioxide. Carbon dioxide means I have carbon with 2 oxygens. You should practice drawing the dot and cross if you don't already remember it from the O-level course. The carbon has 4 of its own, so 4 X's, but it needs 4 more, so it's going to take 2 from each oxygen, and that means that between the carbon and each oxygen I have a double covalent bond. Ethene means I have 2 carbons and 4 hydrogens. That means each carbon will take 2 electrons from the hydrogens, and then it will need 2 electrons from the nearby carbon, so that is a double bond between the carbons. Methanol is carbon with 3 hydrogens and 1 oxygen. The oxygen will share 1 pair of electrons with the carbon and 1 pair of electrons with the hydrogen. Remember that if we have something I can make with a dot, represent with a dot. So for example, the electrons from hydrogen here are represented with dots. The electrons from carbon are represented with X's. So the ones from oxygen will be represented by X's in a circle. So we have 3 different notations, a notation for each element, and that means that this is the kind of structure you have for methanol. Okay, for any question, then he says draw a dot and cross to show the outer electrons. Remember that fluorine is in group 7, so it has 7 and it needs 1 more, so it will donate 1 and share 1 with the silicon. The silicon is in group 4, so it has 4 electrons and it needs 4 from the 4 fluorine atoms around it. Do not forget to put in the rest of the 7 electrons for each fluorine. Okay, what about something like nitrogen monoxide? Nitrogen monoxide means I have nitrogen, 1 nitrogen and 1 oxygen. Okay, how are we going to do this? The oxygen needs 2, so we're going to share 2 pairs of electrons, but that means that the nitrogen here is missing an electron. We have the 5 of the nitrogen plus the 2 from the oxygen, so actually the nitrogen is missing an electron, but that's how it is. Okay, what about BaO2? We're trying to draw the dot and cross diagram for that. Well, between the barium and the oxygen, it's ionic. Barium is in group 2, so it's going to donate 2 electrons, so we have 2 plus. Now, the 2 oxygens have to share electrons, and each of them needs 2 electrons, so it's going to take 1 from the oxygen and 1 from the barium that we took 2 electrons from. So this is what it looks like, and that overall has 2 negative charge on it. What about something like, this is potassium chlorate. So the potassium with the ClO4 is ionic. Potassium gives 1 electron and the ClO4 takes the electron. So I have a K plus and all of this is negative. Now the ClO4, each oxygen has 6 electrons except 1 of them which will take an electron from the potassium. So potassium has donated an electron. Now this will go to one of the oxygens, so that one of the oxygens will share only 1 pair of electrons with the chlorine, while the others will share 2 pairs of electrons because they each need 2 electrons. So in that case, the chlorine has how many electrons around it? 2, 4, 6, 8, 10, 12, 13, 14. It has 14 electrons. So this is what we call an exception to the octet rule. What is the octet rule? The fact that each atom needs a total of 8 electrons around it. Well, some atoms can actually expand their outer shell and take more than 8 electrons. So in this case, the chlorine is using its 7 electrons plus electrons from the other one. So this is a total of 14 electrons. Okay, covalent compounds have low melting point, low boiling point. They are volatile, and the word volatile means they evaporate easily and have low melting point and boiling point. They are usually liquids or gases at room temperature, except bromine. You should know that bromine is the only liquid non-metal. It is a reddish brown liquid. Covalent compounds are insoluble in water, but they would dissolve in organic solvents such as ethanol. Covalent compounds do not conduct electricity, and this is because they have no free ions due to the absence of free ions. Okay, this is new. This year, last year we talked about, or in the previous O-level course, we talked about just ionic and covalent. But here we have something else called a dative coordinate covalent bond. So it's a type of covalent bond in which both the shared electrons are supplied by only one of the atoms. So when we say ammonia, that first diagram is the dot and cross for ammonia. But when I say I'm trying to make ammonium, ammonium is a bond between ammonia and an H plus ion. So the H plus ion is coming in without any electrons, and the bond I'm going to make between the nitrogen and that hydrogen is using the 2 electrons that were lone pairs on the nitrogen. So that bond, both electrons are from nitrogen, that is called a dative coordinate bond, dative covalent bond or a coordinate covalent bond. And you have an overall positive charge on that. So what is happening is the 2 electrons that were lone pair on the nitrogen are used to make that bond with the hydrogen. So this has an overall positive charge. The other type was hydronium ion. So water is between oxygen and 2 hydrogens. But if I put acid into the water, it forms what we call hydronium ion. Hydronium ion is an ion between oxygen and 3 hydrogens, in which one of the bonds is using one of the lone pairs on the oxygen to make a bond with an H+. So that is called the hydronium ion, and that is a coordinate bond. Another example of coordinate bonds or dative bonds is aluminium chloride. Aluminium chloride originally is an exception. It was supposed to be ionic, but actually it is covalent, in which the aluminium makes 3 bonds with the chlorine. But not only that, it also dimerizes. Dimerizes means each 2 of them join together. So they join together because each chlorine on one of the molecules has extra electrons that it can use to make a bond with the aluminium of the other molecule. So chlorine of one molecule using its electrons to make a bond with one of the aluminium on the other molecule. So this is called a dative bond, and this forms Al2Cl6. Another example of a dative bond is between ammonia and boron trifluoride. So ammonia has a lone pair of electrons that it is going to use to make a bond with the boron, and that is because the boron originally has only a total of 6 electrons around it. So BF3, the boron, has 2, 4, 6 electrons around it. When it's present with ammonia, or when it reacts with ammonia, the nitrogen uses the extra electrons to make a bond to the boron. So we have a molecule between the ammonia and the boron trifluoride. If we want to draw that and cross of ozone, this is how we draw it. Ozone is something that has 3 oxygen atoms. So in this case, one of them is going to be a dative bond. So one of them, the oxygen, has its own 6 electrons, plus it's going to share 2 from the other oxygen in the middle. So the oxygen in the middle is using 2 of its lone pair of electrons to make a bond with one of the oxygens, and it is using another 2 electrons to share with the oxygen on the left. Nitrate ion. How do we draw nitrate ion? Nitrate ion means it has 1 extra electron. The extra electron is used to make a bond so that it is added to one of the oxygens, so that that oxygen, instead of needing to share 2 pairs, that will share only 1 pair with the nitrogen, and then the other oxygens, the nitrogen, will use its lone pair of electrons to make a dative bond, and the third oxygen has a normal double covalent bond. Again, nitrate ions, nitrogen with 3 oxygens and an extra electron. The extra electron is the star. Extra electron is put on one of the oxygens, so that is the star. In that case, I need only 1 more from the nitrogen. Now, the other bond here is using the lone pair of electrons on the nitrogen to make a dative bond with this oxygen, and I have 2 electrons that are making 2 pairs of electrons, making double bond with the third oxygen. Okay, N2O. N2O is 2 nitrogens and 1 oxygen, so that is 3 pairs of electrons between the 2 nitrogens, and that means that the oxygen on the right needs to make a bond. It needs 2 electrons, so it's going to take the lone pair of electrons that are on the nitrogen in the middle. you should sit down and try drawing these on your own and try to understand how to draw the dot and cross for these compounds. Carbon monoxide is something that has a triple bond between the carbons. So oxygen originally had 6 of its own. It's going to use 2 of them to make a double bond with the carbon, and then the other one of its lone pairs to make a third dative bond between it and the carbon, while the carbon has its own 2 electrons alone, and the other 2 are being used to make a double bond with the oxygen. So that is how we draw carbon monoxide. Okay, ion polarization. Ion polarization is the distortion of the electron cloud of the anion due to the ability of the cation to attract electrons. Now, when we have a small, highly charged cation, so aluminium with 3+, aluminium is small, it's not huge like barium and so on, and it has 3 positives. This has an ability to attract the electrons that are on the O2- towards it, so that the bond between them is not actually a pure ionic bond. Remember that ionic means that the aluminium gives up its electrons completely to the oxygen, and the oxygen takes the electrons, and that's it. But actually, because the aluminium has a concentrated positive charge, a high charge density we call it, that causes a slight polarization. That means distortion of the electron cloud around the O2- that pulls it a little bit towards itself. Now, what affects ion polarization? The charge density on the cation and the polarizability of the anion. So the cation should be small and with a high positive charge, and the anion should have more negative charge in order for the ion polarization to happen. So which of the following compounds has the most polarized anion? Again, to have a most polarized anion, all the anions here are oxygen. So you are comparing the cations. You need a cation that is small with higher charge. So which of these is small with higher charge? So that is magnesium. Okay. The sodium and potassium have a charge of 1, so that is small. So the choice is between magnesium and calcium. Well, magnesium is smaller, so that's the one we took. Which of the following results in the most polarizing cation? Again, we said that the cation, the positive, should be small and the charge should be large. Electron density maps. We need to learn how to draw electron density maps. Electron density map shows the probability of an electron being present at a specific location. So it sort of shows the degree of covalent or ionic character in a molecule. So for example, if I have chlorine molecule, the chlorines are both equal in attracting the electron to themselves. So the shared pair of electrons are equally shared between them. Notice that each chlorine has 3 energy levels. We're sharing only the electrons in the outer energy level, and that is why you have that wavy shell around it from outside. Lithium iodide. Lithium is a small positive ion, and the iodine is slightly polarized towards it. So this is ionic, but because the positive charge is small and the negative is large, so there is slight polarization. That means that the electron cloud is slightly being pulled towards the positive ion. Okay, structures. We know that we have 2 different types of structures. We have simple molecular structure and giant structures. The simple molecular structures are the ones that have low melting point due to weak attraction forces between the molecules. So if we look at the molecules of iodine, each molecule has a strong covalent bond in the middle, but that has nothing to do with it. We are talking about the interaction between the molecules. The interaction between the molecules are weak, what we call van der Waals forces between the molecules. So these will be easily broken, and that's why iodine has very low melting point. It actually sublimes. Carbon dioxide also sublimes because the molecules are small. Inside the molecule there are strong covalent bonds, but in between the molecules there are weak intermolecular forces that can be easily broken and need a small amount of heat to separate them, so this will have low melting point. The giant structures are large three-dimensional structures in which many atoms are strongly bonded together. So which ones are we going to be talking about? The ones that we talk about that are giant are ionic crystals, metallic structure, diamond and graphite, and there is something called graphene also that we will be talking about. They all have high melting point because there is strong bonds between the atoms in a giant structure, and this needs a lot of energy to be broken. So for example, the ionic compounds have ionic crystal lattice. We said alternating positive and negative ions. So this giant three-dimensional structure with regular arrangement of alternating positive and negative ions, in order to melt this structure, I need to give it a lot of heat because they are held together by strong electrostatic attraction forces between the oppositely charged ions, between the positive and negative ions. When we talk about metals, remember metals are made up of what? They're made up of regular rows of positive ions surrounded by a sea of delocalized electrons. So this giant three-dimensional structure with rows of closely packed positive ions surrounded by a sea of delocalized electrons, there is strong attraction forces between the ions and the delocalized electrons, and that is what makes the metallic bond, and that is why we need a lot of energy to break it. So metals have high melting point and boiling point. Why? Because of the strong electrostatic attraction forces between the positive and negative, the positive ions and the negative electrons. Okay, if we talk about physical properties of all metals, you should remember that all metals conduct electricity, all metals are malleable and ductile, all metals are shiny. Remember that all metals conduct electricity as a solid and molten. And they are the only ones that conduct electricity when solid, except for graphite, which conducts electricity and it's a non-metal. Metals conduct electricity due to the presence of what? Of free electrons, not ions, electrons. Metals are malleable. Malleable means they can be spread into sheets. They're also ductile. That means they can be stretched into wires. Now, why are metals malleable and ductile? Because the layers of positive ions can slide over each other when hit with a hammer, especially when the metal is hot. And you should know that all metals are shiny. Okay, then the other one that we talked about was diamond and graphite. If you remember from the O-level course, we said both of them are different forms of carbon. They're all made up of carbon. So diamond is giant three-dimensional structure in which each carbon atom is covalently bonded to how many? 4 other carbons in a rigid tetrahedral structure. So diamonds are tetrahedral, each carbon covalently bonded to 4 other carbons. That is why diamond is hard. So if we say why is diamond hard? Because of the strong covalent bonds between the carbon atoms in the rigid three-dimensional tetrahedral structure. If we say diamond, does it conduct electricity? No. Why? Because of the absence of free electrons. The carbons have used up all their electrons to make bonds, so there are no free electrons. And because it is hard, diamond is used in cutting and drilling. So it's used in cutting and drilling because it's hard. Why is it hard? Because it has strong covalent bonds between carbon atoms in the rigid three-dimensional tetrahedral structure. Graphite. We said graphite is giant three-dimensional structure in which each carbon is covalently bonded to how many? To 3 other carbon atoms in layers of 6-sided rings with weak attraction forces between the layers. That's how you explain the structure of graphite. Now, because of all of this, graphite is soft, and because it is soft, it's used as a lubricant or a lubricating agent. Now, why is it soft? Because of the weak attraction forces between the layers that allows them to slide over each other or slide past each other. Now, graphite is the only non-metal that conducts electricity. Why is it that it conducts electricity? Because it has free electrons. Each carbon has 4 electrons. It used only 3 of them for bonding because it's bonded to 3 other carbon atoms. So the 4th electron is free to move between the layers. What do we use graphite for? We use it as a lubricant because it is soft and we use it also in electrodes. If you remember when we talked about electrolysis in the O-level course, we use it as electrode because it conducts electricity. Graphene is a form of graphite, but it's only one layer of graphite. So remember that graphite is made up of many layers, but graphene is just one layer of graphite. So it is about 207 times stronger than steel, so it is very, very strong. It conducts heat and electricity because it's like graphite, and is nearly transparent, so this makes it useful in manufacture of things like semiconductors, electronics, battery engines, composites of industries, places where you need conduction of electricity and something that is strong and nearly transparent. Okay, so that's the end of this chapter. Please study it and try the questions.